Alright, so today we're going to be looking at how to use our knowledge of logarithms to solve exponential equations. And this is the primary reason why this is the reason why logarithms were invented in the first place. And today we're going to learn about the magic of logarithms. So, let's look at this equation. So if we were to solve this prior to learning logarithms, what we would have done, first of all, is we would have tried to put these in the same power, so in the same base. So what we can do is we can write this expression as, this is still going to be 3 to the x plus 1. That's going to be equal to, because 27 is going to be, also can be written as 3 to the power of 3 to the 2x. Now what we can do is, next line is going to be 3 to the x plus 1 is going to be equal to, now one of our exponent rules is when you have powers to powers, you have to multiply them. So 2x times 3 is going to give you 6x. So that's going to be equal to 3 to the 6x. And now because these are the base 3, we can say that x plus 1 has to be equal to 6x. As 3 to this has to be equal to 3 to that. That's why those two are going to be equal. And now all we have to do is solve for x. Move one of the x's over here. 1 is going to be equal to 5x. Divide both sides by 5. And what we have here is x is going to be equal to 1/5. And that was our classic way of solving a question like that one. But now what we're going to do today is we're going to do something different. We're going to use logs to solve this equation. So I'm just going to draw a little bit of line here. And now we're going to do this the other method and see which way is better. Well, obviously the log way is better for solving more exponential crazy equations. So we're going to do the same equation, except this time, let's use logs. Alrighty, so what we have to do is first is you're going to log both sides. So what you're going to do, and it's going to be log base 3. And we're going to take the common base of both sides. So this is going to be equal to log base 3 of 3 to the x plus 1 is going to be equal to log base 3 of 27. I'm going to have to start a new page because it's getting a little bit tight here. So, just going to take a new page here. So I'm just going to write the question down again. So 3 to the x plus 1 is going to be equal to 27 to the 2x. So how are we going to solve this one? So you're going to take, so what you want to do, you want to take a log, but you want to take the same base. So this one we're going to take base 3 logarithm. So it's going to be log 3 of 3 to the x plus 1 is going to be equal to log base 3 of 27 to the 2x. Now one of our log laws was that we could take this top number, or this top expression, we could put it on the front. So that's what we're going to do now. We're going to take x plus 1 and put it like that. So x plus 1 log base 3 of, now it's only 3 left, right? And the same thing here, we're going to take this 2x and we're going to put it to the front. So that's going to be equal to 2x log base 3 of 27. Now the reason why we chose log base 3 instead of any other log was so that we could take this 3. Now basically what this is saying that is 3 to what power is going to get you 3? Well, 3 to the 1. So that's going to be equal to 1. So x plus 1 multiplied by 1. And that's the exact reason why we chose base 3 there. Because we wanted to get rid of that log. We want to get rid of that 3 so we can just solve for x, right? And the same thing here. Now 2x. Now this is basically saying 3 to what power is going to get you 27? And obviously 3 cubed is 27. So this is going to be equal to 3. So now simplifying it out, x plus 1 is going to be equal to 6x. Move the x on this side, 5x is going to be equal to 1. And x again, therefore x is also 1/5 here as well, which is the right answer. Now, those are two different ways for solving exponential equations, and you will love this method after doing some really harder questions. For these simple ones, you could have used both methods, but it's just easier to use some other ones as well. So, let's do a little bit of a harder example now. And now we're not, forget about using the old method. We're always going to use this new method that we just learned today. So, keeping rolling here, let's choose a new question. So the new question right now that we're going to be doing is, now they're going to get a little bit tougher, so 2 to the 3 to the x is going to be equal to 6 to the x plus 1. Now that is our new question. And they do get trickier, but they have the simple method, and if you do it step by step, you'll be getting 100% on these questions. So, starting off, what we're going to do, the first thing we're going to do is we're going to log both sides. That's always what we do. And we're not going to choose a base here just yet, so let's just do, we're going to log both sides, just plain and simple. Log of 6 to the x plus 1. Now, what we're going to do now, we're going to use some of our exponent rule, or some of our log laws to simplify this expression out. So what we're going to do now is that we're going to, because of our product rule, when there's a product, we can expand it out as an addition statement. That's one of our log rules. If you're not sure on that, just quickly check up on those log rules before you watch this. So this is going to be equal to log base 2 plus the log of 3x. I didn't mean to say base 2 there. It's just log of 2 is equal to. Now, for this side, we have to use a different property. Now, this one we have to use the power property. We can take this power and we can put it on the front. So that's going to be equal to x plus 1 log of 6. Now, what we're going to try to do here is we're trying to solve for x. So having an x in the power is not beneficial to us at all. So what we're going to do here, we're going to take this x and we're going to put it on the front as well, that's one of our log laws. And one of the most important ones too. So now this is going to be equal to log of 2 plus x log of 3 is going to be equal to x log of 6 plus log of 6. So I just expanded it out there so we can, again, our goal is to solve for x. So that's why we want to get the x's out. So once we've done that, our next step should be to move the x's to the one side so that we can take a factor out of the x and simplify it. So let's put the x's all on the left-hand side and put the other ones on the other side. So it's going to be equal to x log of 3 minus x log of 6 is going to be equal to log of 6. And we're going to take this log of 2, put it on this side, so it's going to be minus log of 2. So now what we can do, we can factor an x out of both of these, and that's what's going to allow us to solve for x eventually, right? So what we're going to do now, we're going to take out an x. So it's going to be x log 3 minus log 6 equals log 6 minus the log 2, and then our last step is just dividing both sides out so that now we just have to solve for x, and this is the fun part here in a way, right? So x is going to be equal to log of 6 minus the log of 2 divided by log of 3 minus log of 6. And now if you punch all that big equation into your calculator, got my TI-84 here, so it's going to be log of 6 minus the log of 2, and I'm going to do log of 3 minus log of 6, and I divide those two, log of 6 minus log of 2 divided by log of 3 minus log of 6, and I get a value that's close to negative 1.58. And if you punch that into this original equation here, you'll see that it is an accurate value that will work in that equation. That's how you solve a logarithmic equation. And yeah, that's basically the magic of logs. If solving for that x without using logs, you'd probably be doing it for the rest of your life because it would take so long to do it with the trial and error method. So this is one of the greatest methods that has been invented, and it's one of the greatest things that ever existed. So let's do another example. It's going to be a similar example, so let's do this next one. Alright, so now this one is going to be 3 multiplied by 12x is going to be equal to 9 to the x minus 1. So again, our first procedure is going to be take the log of both sides, log base 10 in this case. Well, not at all. Generally speaking, you would take a log base of 10. So what you're going to do, you're going to do log of 312x is going to be equal to the log of 9 to the x minus 1. Now again, using our properties, we're going to try to solve for x. So again, we have to use the multiplication property here. We can write the logs as an addition statement, and one of our log laws says that. That's going to be equal to log 3 plus log 12x is going to be equal to, now this property, we can use this power property and put the power on the front. So that's going to be equal to x minus 1 log of 9. Alrighty, so now what we're going to do, it's very similar to the last question. So what we're going to do, we're going to put that x on the front part as well using a property. So it's going to be log of 3 plus x log 12 is going to be equal to x log 9 minus log of 9. So now again, we're trying to solve for x, so you're going to move the x's to one side. So what we're going to do here is we're going to move the x's to one side. So x log 12, take this over here, minus x log 9. And we're going to do minus log 9. Take the minus log 3 over there. And now we're going to factor an x out to solve for it. So you factor the x out, and it's going to be equal to x log 12 minus log of 9 is equal to minus log 9 minus log of 3. And therefore, for our final answer, x is going to be equal to minus log